Right, hello everybody. Good morning, good afternoon, and good evening, wherever it is for you while you're watching this. We're going to move on in this video with topic 4.1, which is Introduction to Water Systems, as you know. And I just want to focus in this one on the water cycle, or as the IB syllabus likes to call it, the hydrological cycle. I'm just going to call it the water cycle because I'm kind of old-fashioned like that. This is the third cycle we've looked at. We've already looked at the carbon cycle and the nitrogen cycle, and this one is by far the simplest of the three of them. It's basically just the transfer of water from place to place. So we can think of the water cycle as a system, and like any system, it has inputs, outputs, flows, and storages. So basically in this video, I'm just going to give you examples of each of those four things. So I know I always say this, but it should be a very short one. That won't quite bring us to the end of topic 4.1. I still need to cover, and I'll do it in separate videos, so this isn't just one huge video. I also need to cover human effects on the water cycle, how humans interfere with it, and the other thing we need to look at is how ocean currents are formed and how they move. This is another one of those topics where it's a bit all over the place. So I'm just trying to focus on very specific things on each video. Okay, let's move on and take a look at the syllabus. It's fairly straightforward. First of all, the first bullet point here is a statement of fact. The water cycle is driven by energy from the sun, by solar radiation. Although I've already said that the water cycle is a system in which matter is involved, water particles, it needs to be driven by energy, and that energy comes ultimately from the sun. Then these next two bullet points, you need to know examples of storages in the water cycle and examples of flows. You can take a minute to read those, but I'll go through them when I show the diagram anyway. Hopefully I'll cover all of them. And then finally, in applications and skills in terms of the water cycles, it says you need to construct and analyze a diagram of the water cycle itself, which is what I'm going to show you on the next and final slide. Okay, so here's a very simple diagram of, or very simple system diagram of the water cycle. Like any system diagram, it's up to you really where you set the boundaries of the system. The system needs to have boundaries. The water cycle can be, you can do it on a very small scale, on a very local scale, or it could be pretty much on a global scale. On this diagram, these kind of arbitrary boundaries are set from the mountain to the start of the open ocean, I guess you could say. Okay, so let's go through all of these things. We'll begin with inputs. Well, usually on a water cycle system diagram, there's only one input, and that input is precipitation. So water comes in the form of rainfall or maybe snowfall. There's probably one exception to that. You could say that, depending on the boundaries again of your system, you could say that water can be inputted by human activity or humans physically moving water supplies. A very good example of that, a good case study that we're going to look at further in the class, and I think we've already spoken about already, is the movement of wastewater from Mexico City, where we live, where we are now, to the Toluca Valley. And the Toluca Valley is the largest area in the world that's irrigated for crops by human waste or human wastewater. So virtually all of the wastewater from Mexico City is sent to the Toluca Valley to grow crops. That's an example of an output of water from Mexico City and an input into the Toluca Valley. Interestingly, there are plans, because the groundwater is being filled up by this wastewater that's going through the soil, there are plans to bring back clean water, clean groundwater from Toluca Valley back to Mexico City in reverse. Okay, so that's pretty much the only inputs that I could think of. Outputs, well, I already mentioned human outputs of water. Outputs could be runoff across the surface and movement of water from streams and rivers maybe to the open ocean. That could be another output. Another output you can see here, another two outputs. One is evaporation, which is obviously just the change of state from liquid water to water vapor by, again, driven by solar energy, or transpiration. Transpiration is the evaporation of water from the leaves of plants that pulls more water up through the roots of the plants. Together, very often scientists will call that one process and they'll refer to it as evapotranspiration. One word. Okay. That's the only output. So that's fairly straightforward, input, output. In terms of flows, a bit more complicated, I guess you could say. First of all, although it's not actually listed on this diagram, the movement of water from the surface through the soil is called infiltration. So infiltration of water from surface through soil. Obviously that depends on how easily it is for water to run through the soil. If soil has a very high clay content, very small particles, it doesn't let much water go through, and that water would become waterlogged. I've already mentioned wetlands and salt marshes. So inland, a wetland is caused by permanently flooded soil where the water can't infiltrate through. Another word here is percolation. Percolation is the word that's used to refer to water moving from the soil through the rock. And again, some rocks will allow water through and some rocks won't. That's called the permeability of the soil, how big the pores are that allow water to move through. So for example, limestone is very permeable. It allows water to go through very easily. Volcanic rock doesn't have those pores and it won't really allow water to go through. It has very low permeability. So the water can't percolate through. I've already mentioned surface runoff. That could be a flow. Stream flow again could be a flow if it's not an example of water leaving the system. Surface runoff occurs basically when the soil is already saturated, so it can't infiltrate, or it occurs when the rate of precipitation is greater than the rate of infiltration through the soil. Okay. And another example actually of flows could be ocean currents, but as I said already, I'm going to cover that on a different video. And another example that it states, you might have spotted in the syllabus, is advection. Advection is basically the movement of clouds driven by wind. And by the way, you should know why winds are formed or what drives winds. Winds are driven by solar radiation. And we already saw in the syllabus that all of this movement of water is driven by solar radiation. So that's a nice one. Advection is the movement of water by winds in the form of water vapor or clouds. Okay, so that only leaves me with one other thing, storages. So examples of storages, I've written a few down here. Well, storages occur in living things, in the soil, in water bodies like lakes and rivers, in groundwater. Groundwater is a good example of storage. Groundwater is water that exists in rock as opposed to the soil. In between the soil and the rock, you've got something called a water table. It kind of crosses between the two, between the sediment or the soil and the groundwater or the aquifer. And the water table is water that's more or less fairly easily accessible to humans. Okay, the water table is an example of water that can change seasonally. So if you have a lot of rain, like we do in the rainy season in Mexico City, then the water table will rise. And if you go for a long period without rainfall, the water table will drop. The water table and the aquifer underneath is being overexploited in Mexico City. You must realize this. So the reason why you don't see any straight buildings in the Centro Histórico of Mexico City is because so much groundwater is being taken away. The rock that's normally supported by the aquifer is starting to collapse, and basically the center of Mexico City is sinking. The reason for that is that Mexico City is overpopulated, and the only way to get enough water for the population we have in this city is to extract it from groundwater. Water supply in Mexico City is already a big problem, and it's going to become a bigger problem in the future. Okay, one other store is ice and snow. By the way, that's called a cryosphere, permanently frozen. Water bound up in the cryosphere can be seasonal, and as seasons change, water can be released, and as the seasons cool, water can be bound up again in ice and snow. That's normal. What's not normal is the accelerating release of water from the cryosphere driven by climate change and global warming, which we'll cover in again when we talk about global warming. Okay, so pretty much that covers that diagram. I'm sure you'll agree it's fairly straightforward. One nice thing about the water cycle that I've stated in this box up here is it occurs in the atmosphere, the lithosphere, and the biosphere. It kind of covers pretty much the whole planet, the water cycle. Okay, hopefully I've covered everything that's in the syllabus. Please make some notes from this video as we go through it, as I set it for your work, and we'll speak about it in the classroom. And like I always say at the end of these things, please take care of yourself and your family during this pandemic. Take a lot of care, and hopefully we're back in the classroom before too long. Okay, goodbye then, everybody.